All right, here we go. We're looking at three-dimensional shapes. Typically, surface area we start off, and at the end of the chapter, we're doing volumes. All right? So here we go, 12.1, starting off with what we would call the outside of a shape. Okay, it is actually the shape itself. When we speak about the outside, we mean kind of these edges. But let's talk about the shapes themselves. What are they called? The first one I'm going to draw for you is a pentagonal prism. And the best way to do this is you take a duplicate of your base, lift it off the ground, and then you construct your vertical edges as they were. And now we have a polyhedron, three-dimensional, and this one here is a pentagonal prism. More about prisms in just a moment. But no, it's a 3D shape. Lots of things we could look at, but initially, first of all, why is it called a prism? The reason is because there is a constant stack of bases. All right, meaning here is my base. And if I get a bunch of those and stack them on top of each other, eventually I end up with the full three-dimensional shape. To illustrate that, let me start with what I would describe as a loaf of bread. All right, so I duplicate it, sorry, not a loaf of bread, a slice of bread. And I duplicate it again, and I duplicate it again, and I duplicate it again, and eventually we end up with something that might look like a loaf, at least half of a loaf anyways. And this is kind of a prism, again, because there's one constant shape. Be careful. One last thing about prisms. When I do what we would call a cross section, and you'll talk about this more in the future when you're in calculus possibly, that is what we would call a cross section if I take a knife and cut it sideways, okay? And that's kind of what the shape I would get when I'm done. Now, if I were to cut it vertically, up and down, I would end up with this kind of shape. And that, you can see, would not remain constant, because if I cut it over here, I'd get a smaller rectangle. All right, and I could get other cross sections too, but those are kind of the more popular ones that you would see in that cross sections. All right, so prism, constant stack of bases. Lateral edge. The lateral edge refer to what we would call the side edges. These are vertical, usually, not always, edges. And likewise, the lateral face, again, it's two-dimensional. Some people refer to it as a side. That's kind of informal. We would call that the vertical face. More importantly, that is perpendicular to the base. So let me zoom out a little bit here and show you in this diagram here to the right. Here is a lateral edge. Notice it is perpendicular to the base. This one actually isn't quite perpendicular, but notice our base is at the bottom, and here's our bases at the top, and so these would be then known as the lateral edges. All right? Whereas the vertical faces now is a two-dimensional shape, so that's this. Yeah, there's one, and then there's another one back here. And then there is a third over here, okay? So those are in essence, the sides of the shape. If I add them all up, all those areas, we get the lateral surface area. So we add up all the faces that are not the bases. Ha, 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 ha. Okay, so they're perpendicular to the base usually. even though it doesn't need to be actually perpendicular, it could be oblique, you would still get the lateral surface area. So here's our formula for what we would call then the total surface area. I prefer just to call it the surface area because when we say surface area, we mean everything, okay? And again, this works for a prism. We're going to take the base, kind of working there in the background. You hear the jazz bass playing. I don't know if you can hear that or not. But we have two bases, the top and the bottom. And then we have what is known as the lateral area, right? All the faces added up. So first of all, find the area of that base, whatever it is, multiply it by 2. All right? And now you could take all the sides and add them up. All right? So this piece over here could be like the sum of all the sides. But there's another clever way to think about it. And let's go back to my original shape to illustrate. All right? Here I have a pentagonal prism. And again, hopefully you can see there's one of my lateral faces, and here's another lateral face. And I want to add these all up. So hopefully you can see that there's 5 of them. And so if I take and strung them all up, see if I can get them to fit here. There's 3, and a 4th one, and a 5th one. Okay. Something kind of interesting happens because they all have the same height. So this is, in essence, one big long rectangle, yeah, with one particular height. And that would be whatever the height or the lateral edge of that shape is. And then my edges down here on the bottom end, these end up wrapping around my shape. Yeah. So those edges going around is also known as the, starts with a P, big long word, not pentagonal, the perimeter, correct, of the shape, which we would then multiply times h. All right, so that's what you would do for the area here formula, is I would take the lateral area, which is the perimeter, times the height of the shape. Or again, this again can be thought of as the lateral edge. Hopefully that makes some sense to you as you work through the homework problems and you're able to do those without too much difficulty. Again, we're looking at surface areas of polyhedrons, mainly prisms.